Hi and welcome to day 4 of Just Start Programming, creating console or terminal apps using Rust and Ratatouille. Today we'll go through the concepts of Ratatouille, and if we have enough time, we'll cover some examples of the widgets. So join me once again live in one take, no shortcuts, no secrets. So let's just start programming. All right, so here we are. Concepts. So I've already opened the pages because yesterday I think my internet connection was not that good. So instead of wasting time waiting for the page to open, I already opened it here. So we'll start going through the concepts, the widgets, layout, event handling, builder light pattern, rendering, what's under the hood, application patterns, Elm architecture, component architecture, flux architecture. I think I missed this one also. Maybe let me open it here. Backends, comparison, raw mode, alternate screen, mouse capture, and yeah, so let's go through these things first. So I'm not sure if we are going to code some of this, but it's also important to understand the concept. Okay, so let's start. Concept, so we'll cover rendering, layout, application patterns, backends, and event handling. Let's start with widgets. So with widgets, they are the building blocks of user interfaces in Ratatouille. They are used to create and manage the layout and style of the terminal interface. Widgets can be combined and nested to create complex UIs and can be easily customized to suit the needs of your application. So Ratatouille provides a wide variety of built-in widgets that can be used to quickly create UIs. These widgets include, okay, so you have block. Example is here. Let's open this up. So block will look like this. Oh, there's a GitHub page. Ratatouille git branch latest. Then Ratatouille. Okay, so I think there's some example codes there. Maybe the code will be here. Okay, the code is here as well, so we can take a look at the code here later. So this is how a block will look like. You have borders all, so it will be enclosed in borders. Border none, border left. So similar as what you can see in Excel, you have borders. Yeah, but this one is also nice. You have rounded edge borders. can have double as well, and then thick. I think with thick, the character is bold, it seems. And then you can have a styled block, styled borders, styled title, I mean, top left, top center, top right. Okay, so you have all of these interesting looking combinations. So what we have here under block, okay, the usual libraries. Of course, you'll have the widgets, block, borders. Padding and paragraph would be the one inside the borders. And you have init and restore, and inside run, this is run where you have the terminal as the parameter, and you have a loop to draw function. So this is where the borders are implemented. Render borders paragraph. Okay, so there's this function render borders. Render borders. Yeah, you have an input paragraph, border, and then the frame. Then here, render borders. Okay, we're passing in border. So borders all. Okay. So here are the different variations for border. Yeah. So that's for block. Then we have bar chart, displays multiple data sets as bars with optional grouping. Let's take a look at the example. Oh, nice. You get to see this interesting looking bar charts. It looks like, you know, in most stereo systems where you have the equalizer. So it looks. So how do we use bar chart? And draw. So here in draw you have layout vertical, constraint, length 1. We have render widget, bar chart, vertical bar chart. Okay, so vertical bar chart, you have a vector of bars. Temperatures. Okay, iterating through the vector where you have a map. Map will have a closure having R and value. So the vertical bar, R and value, dot collect. Okay, so you'll have bars. And bars is being used here. So this is the actual widget, bar chart. Default data, bar group, default bars. Okay, so there's a reference to bars. Block new title bar width 5. Okay, let's not try to understand each and every widget. This is just a quick quick overview of what are the possible widgets. Yeah, but we'll have some time to implement that later also. And then calendar. What can you see from calendar? It's a calendar picker that looks like this. But I think what would be more interesting is that this automatically computes the dates, the day and the dates in the calendar. So let's try to see, run, here's your loop, draw, from draw, offset date time, now local. Where's the calendar widget here? Render widget. Okay, render widget is here, where you have cows. What is cows? Cows, get cow. Calendar event store. Okay, here, cows. Get cow. Where's the calendar widget? Maybe what we can do is open up this one. Okay, Ratatouille widgets calendar. Struct monthly. Available on create feature widget calendar only. Okay. So monthly is the widget. Do we have month? Oh, okay. So here, monthly. Show weekdays header. Does it automatically compute? Show month header, show weekdays header, render. Okay, display a month calendar for the month containing display date. Display date. Okay, so here's the date. So it's based on a certain date, then it will render the month. Okay. That's for calendar. About canvas. Canvas draws arbitrary shapes using drawing characters. Okay, so Ratatouille widgets canvas. Does it do? Canvas default, your bounce, paint. Okay, so I think you can draw inside the canvas. You can draw a line, you can draw shapes, rectangle. It's like the canvas in JavaScript also. Oh, nice. So you can have something like this. So you can draw a map. But how can we draw these blocks here? Is this some kind of font? Okay, let's inspect it a little bit. App. Okay, so you have ball, playground, tick count. But what's interesting is the world map. World map. Okay, let's see how the world map is being drawn. Mouse event, on tick, draw. Okay, here, draw map canvas. Okay, map canvas. Map canvas is here. Canvas marker paint. Draw map. Draw map. And where's map? Map. Okay, so does it mean that there's a fixed map like here? So you don't have to draw it yourself. You just make use of this map widget. It will draw the map. It would be also nice if it can have like an indicator over here. Okay. I think the palm canvas, this could just be a circle. Palm canvas. Block bordered palm, self ball. So there's a ball. Where is ball? Ball, self ball. Ball X radius. Okay, ball is a circle here. All right, so that's good to know. You have that option as well. Close this, and then chart. Displays multiple data sets as linear or scatter graph. Okay, let's try to see how it looks. Can have something like a sine wave using charts. Or you can have a line chart, you have a scatter chart. I think this would be nice if those who are into machine learning, so instead of plotting it in Python, so maybe can do something different like this, make use of charts. Yeah, one of these days we can try it out also. Okay, so for charts, yeah, so you have a specific widget for it, chart, and then signal, sine signal. Okay, sine signal. What's a sine signal here? Render scatter. I cannot search for it. Sine signal. Render line chart. I think line chart is quite straightforward. What is this? New. Okay, so this one is a bar chart. How is it doing the sine? Render animated chart. Data sets. You have a data set. X-axis. Y-axis. Oh, sign signal is here. Okay, sign signal is here. So you have different points. 0.2, 3.0, and 18. Run. How is it actually rendering the animation? I think from here, chart 1. Okay, chart 1, and then you have the X and Y axis being animated. So let's search for chart 1. Chart 1, chart 1, chart area. Line chart. Scatter chart. Oh, that's it. But where's the chart 1? Where's the chart 1? Okay. Chart 1. Chart 1. Maybe just chart. Bar chart. Line chart. Line chart. Scatter chart. But where's chart 1? Line chart, scatter chart. Is it by default? It's going to be chart 1. Let's take a look here. Can't seem to find the chart 1. Okay, we know that it's a chart widget. Something is missing. I don't know where it is. So that one is a bit mysterious. Where is the chart 1 coming from? Okay, let's continue. There's still a lot of widgets here to cover. So chart and then clear. Okay, so clears the area it occupies. Useful to render over previously drawn widgets. Okay, so I think this is just one invocation of a function. Clear. And then you have gauge. Displays progress percentage using block characters. What does it look like? Block characters. We'll come back to that. Line gauge displays progress as a line. Okay, let's just open these things up. Sorry for that. I should have done it earlier also. Okay, anyways, we know that there are these widgets. We might have seen it from some of the demos also. Okay, so it's good to know that there are those available widgets. And additionally, string, reference to str, span, line, and text can be used as widgets, though it's common to use paragraph instead of this directly. So inside the paragraph, you can still make use of this. For more information on these widgets, you can view widgets API docs and widget showcase. Yeah, so we don't need to memorize everything. We can always refer to the documentation and see how it is implemented. Oh, it's quite strange. I'm streaming, but I don't have internet. Okay. Oh, there. What is one? List. Oh, list. So it seems like for list you have this selector that is rendered, or here you can have sure if this is going up or going down. Is it going up or going down? If you are scrolling down, then the characters are going up. So maybe you are going down and then the characters are going up. So what do we have? List item, list state. I think these are the things here that is used for list. Okay, to-do list. Yeah, so it's a list, so most likely you'll have some iterators also. List state default. Maybe this has something to do with which list is being selected. Key code Q H J HJK G, capital G. Oh, I think these things are like VI controls. So if you're using VI, then J is going down, K is going up. Yeah, J, K. That is for list. How about this one? Scroll bar. Yeah, scroll bar is nice. This looks like a proper console application. Seeing all these tiny arrows, you have this thick bar here. Wondering if you can use mouse for this as well. Or here HJKL. Yeah, so this is VI controls. How you move up and down, left and right in VI. So you can have scroll bar here. You can have scroll bar here as well. This one also looks nice. So you have what is here? For widgets, you have block, paragraph, scroll bar, scroll state. All right. So it's basically a block with some scroll. This one looks nice as well. I think this would be nice if you are displaying your memory or CPU utilization or your network. Yeah. So what are these? These are Sparkline. Okay, Sparkline widget. Sparkline widget. Okay, here, Sparkline. Render widget, Sparkline, chunks. Data. Data 1. Self data. Table. Ah. So if you have table, okay, I think the scroll for table could be included in the table, I assume. So you still have block table, or are you going to attach the scroll bar to a table? Let's see. For table state, you have table state, scroll bar state. Okay, run, loop draw. Okay. Key events are here. Okay, when we are drawing it, you have render table. Okay, so render table selected. Okay, so the styles are here, the header is here, the rows from a vector perhaps, and then table. Okay, table is here. Table. Row height style. Okay, so if you have the table, you specify the header, styling to highlight also, background, highlight spacing. Oh, the scroll bar is separate. The scroll bar is separate. Render scroll bar. Okay. Where's the table? Where's the table? Okay, render, that's render table. Then render scroll bar is here. Then footer. Okay, so that is clear. Render scroll bar is separate. What else? What other widgets? Tabs. Gauge would be nice. Okay, tabs. Yep. So this looks like a proper application also. But I think the tabs are static. So 1, 2, 3, 4. You cannot move the tabs around. That's my assumption. Okay, so that's for tabs, and here, gauges. So if we are processing a file maybe, then we can display something like this, percentage, like copying or parsing or transforming some of the data contents into some other format, yeah, we can make use of gauge. Okay. Clear is just a render widget clear by itself. Clear the area. Layout. Right. We done with the widgets? Not yet. Okay. So those are the things. So widget traits. In Ratatouille, widgets are implemented as Rust traits, which allow for easy implementation and extension. The two main traits for widgets are widget and stateful widget, which provide the basic functionality for rendering and managing the state of a widget. Additionally, the widget ref and stateful widget ref trait allow for rendering widgets by reference, which can be useful for storing and rendering collections of widgets. The later two traits were added in Ratatouille 0.26 and are, at the time of writing, gated. Gated by an unstable feature flag. So there may be limited third-party use of these traits. All the internal widgets have been updated to implement the reference traits. And there is also a blanket implementation of widget for reference to T, type T, where T is a widget ref. I don't understand what gated means. So I think some traits are not allowed, perhaps, or it's just my assumption. Once again, I might be wrong, but probably somewhere we'll find out about it by reading through the document also. Okay, widget. So the widget trait is the most basic trait for widgets in Ratatouille. Provides the basic functionality for rendering a widget onto a buffer. Okay, so trait, widget, then you have a render function. Then stateful widget. Stateful widget trait is similar to widget trait, but also includes a state that can be managed and updated during rendering. This one doesn't have state. Here is a type state. Okay, so I think this is where you maintain the state of the widget. This one, or you're passing it here also. In the previous example, the state is kept in, where was it? Yeah, the app.rs. App.rs, where it's using this struct to hold information. Yeah, but in this approach is a bit different. Okay. Widget ref and stateful widget ref. So widget ref trait allows for rendering a widget by reference instead of consuming the widget, which can be useful for storing and rendering individual or collections of widgets. Individual or collections of widgets. How does that work? Okay, widget ref, render ref, area rect, which is a rect, and then you have buff as a buffer. So stateful widget ref trait is similar to widget ref trait, but also includes a state that can be managed and updated during rendering. Okay, these two traits were introduced in 0.26 to help avoid shortcoming that meant that widgets were always consumed on rendering, while not breaking all code that has previously been built with that assumption. These two widgets are currently marked as unstable and gated behind. Oh, unstable. Okay, so maybe what that means we avoid using it for now. Using widgets. In Ratatouille, widgets are used to create and manage the layout and style of the terminal interface. Widgets can be combined and nested to create complex UIs. Can be easily customized to suit the needs of your application. To use widgets in your application, you will typically use the frame type, which has two methods for rendering widgets: render widget and render stateful widget, and the corresponding _ref methods. These methods are the entry points for an application to draw widgets and are usually called from the closure that is passed to terminal draw. Okay, so we have seen this before, where you have the frame and render the widget. Maybe here we can inspect. Main run app. From run app you have the draw. Okay, then you have the frame here, and it's calling the UI. So the UI will have, okay, all the way down here you have render. Yeah, render widget. So frame, render widget, and then the widget. Frame, render widget, some widget. Okay. Here's an example of render stateful widget method to draw a stateful widget. Okay, so from here it looks similar. The only difference is the function and then some stateful widget, frame area, and mutable at some state. These methods internally call the render function on the widget or stateful widget trait, which will then call the render function on the specific widget ref or stateful widget ref that you have implemented. Common compositional pattern is to only have a single root widget, the abstract in the example below, that is passed to the frame render widget, and then within that and other widgets you call the render methods directly passing in the area which you want to render the widgets to. Okay, so you have the struct app, terminal draw, closure, and then frame render widgets app. Okay, where app is the one implementing the widget. So if you're implementing the widget, then you need to implement render. And then you can put, yeah, in this case, as an example, my header widget or some other widgets inside. Okay, implementing widgets. In Ratatouille, widgets are implemented as Rust traits, which allow for easy implementation and extension. The two main traits for widgets are widget and stateful widgets, which provide the basic functionality for rendering and managing the state of a widget. Here's an example of implementing widget trait for a simple greeting widget. Okay, so you have a struct greeting widget which holds name as a string. Then implement widget for greeting widget. So since it's a widget, it needs to implement render. Then here, say you have this string greeting from buffer, set string, area x, area y, the value of greeting, style default. Okay. In this example, greeting widget such a struct has a single field name. Okay, so I think this is the explanation part of what I mentioned. Widgets are not restricted to just calling methods on buffer. Buffer is here. They can also create and render other widgets within their render method. For example, instead of directly calling methods on buff, widget can create a line widget with a vector of span, where the span for the name is styled. This line widget can then be rendered within the widget's render method. Okay, let's see. Greeting widget render. Okay, buffer is here. Buff. Okay, so you can have line.render area buff. Yeah, so what it was trying to say is you don't have to call the methods in buff. A widget can create a line widget with a vector of span where the span for the name is style. This line widget can then be rendered with the widget's render method. Okay, so you can have a widget and then call the render also. You pass in the area and then the buffer. So let's try to see from the example render widget. Render widget list. We have render widget. Okay, footer chunks 1. Mode footer. Where's mode footer? This one doesn't seem to call the render. So I'm wondering. This part, line render. Okay. Maybe if we search for render widget. No, from the example, it doesn't render. Okay, exit paragraph. Okay, so it's a paragraph. It's just the widget, but it doesn't call render explicitly. Or probably if you pass it here, automatically it will call the render for that particular widget. Okay, because we're not seeing any render here actually. Yeah. Maybe we'll try that one out later also. I mean, not today, but some other time. This approach allows for composing and reusing widgets. For example, the line widget can be used in other widgets or even in other parts of the application. Additionally, it allows for easier testing and maintenance of widgets as the code related to rendering is organized in a consistent place. Implementing stateful widgets. So in some situations, a widget might need to be able to mutate some extra state while rendering itself. An example of this is how the built-in list widget works. During rendering, the list updates the scroll position in the state to ensure that the selected item is visible in the rendering area. Here's an example of implementing stateful widget. Okay, so say a frame count widget and stateful widget. Frame count widget. Okay, so stateful widget will have render. And then you have state here. Okay, so the state is incremented. So the star is, what was that? Dereferencing state, star state. And then here, line, because it's line, then you can see render here. That's interesting. Maybe this is only for line. In this example, the frame count widget increments the state every time it is rendered, counting the number of frames. Implementing widget ref. In Ratatui 0.26, we add the widget ref and similarly stateful widget ref traits. These allow widgets to be created that are rendering by reference because of the ref here, which can be useful for, so this is useful for storing a widget that can be rendered multiple times instead of constructing it on every frame. Okay. Rendered multiple times. So that's why there's a reference. This also makes it easy to create dynamic collections of widgets. Example, panes in the layout by boxing the widget using box dynamic trait. This one is also quite interesting, but I think this is already quite advanced. I think here in the example, we don't see any box here. Let's check. Box. About widget ref. Implementing widget ref and stateful widget ref is similar to implementing the consuming versions of the traits. The difference that being that the method's name is renderRef. Self is a reference. Widget ref. Which one is the reference now? Self as the reference. Is it this one? Let's check the other one. Stateful widget is like this. But if it's widget reference, then you have ampersand self. All right, thank you for subscribing. Can we close this? Okay. Okay, so that's the difference. This can be useful as a way to store the widgets between frames. How is it being stored? Okay, greeting widget, render widget ref. Okay, so a reference to app greeting. In situations where there is a collection of widgets of different types, or a single widget that doesn't have a type known at compile time, the ref traits make it possible to store widgets as trait objects by using box. So you're enclosing it inside box. Example, the following code shows how you might have two different widgets. Okay, two different widgets stored in a vector that are later rendered without knowing the type of each widget at runtime. Okay, so you have two different widgets, greeting and farewell. Then here it is stored in a vect, but wrapped inside box. Okay, so box new, then you have greeting, box new, farewell. So that from here, from widgets, widget.render ref, render ref. Render ref. Is it that one or render widget ref? This is from frame. But here widget is widgets, which is a vector containing box of greeting. I think something is missing. Okay, maybe this is a code snippet. All right, let's move on to layout. So what do we have here in layouts? So you have a coordinate system, runs left to right. Okay, left to right, and then top to bottom. Okay, so 0, 0 is top left corner of the terminal. And X and Y coordinates are represented by unsigned 16 values that are generally listed in that order in most places. Okay, so if you have 80 characters for X, yeah, but when we are resizing the terminal, it's not always 80 also. I'm not sure how that is being handled. Maybe not yet. Maybe let's find some answers here. Layouts and widgets form the basis of the UI in Ratatouille. Layouts dictate the structure of the interface, dividing the screen into various sections using constraints, while widgets fill these sections with content. So layout is like the container where you have constraints. And then widgets goes inside that container. When rendering widgets to the screen, you first need to define the area where the widget will be displayed. This area is represented by a rectangle with a specific height and width in the buffer. You can specify this rectangle as an absolute position and size, or you can use the layout struct to divide the terminal window dynamically based on constraints such as length, mean, max, ratio, and percentage. Okay. The following example renders hello world 10 times by manually calculating the areas to render within. Okay, so you have for loop. Okay, so this is from 0 to 9 actually. And I, so you have a rectangle, new. Okay, so maybe x1, y1. Then you have x2, y2. Render widget, paragraph, hello area. So the layout would be rectangle. And the layout struct. A simple example of using the layout struct might look like this. Okay, so you have a specific layout widget. No, layout is layout. Okay, so we have seen this yesterday. So vertical means y. But if we have constraint like this, then it will cut it horizontally. So this is vertical, and then cutting it horizontally. So 50% here above, and then 50% here. Okay. In this example, we have indicated that we want to split the available space vertically into two equal parts. That's why you have percentage 50. The split function takes the total size of the terminal window as an argument, returned by frame area. Returned by the frame area. Okay, so you need the frame area, so you should be able to split it into this percentage. Okay, and then calculates the appropriate size and placement for each rectangle based on the specified constraints. Once you have defined your layout or a set of nested layouts, you can use one of the rectangle areas derived from such layout to render your widget. This can be achieved by calling, okay, here you have render widget again, or frame render stateful widget. Bottom, yeah, okay, so as compared to line, you see paragraph here, it doesn't call the function render. So you'll just have paragraph like this. This might look something like, okay, you have top and you have bottom. Yeah, so 50%, 50%. In this example, two paragraph widgets are generated named top and bottom. These widgets are then rendered in the first and second areas, layout 0 and layout 1. 0, okay, and layout 1 of the split buffer, respectively. It's important to note that layouts return an index list of rectangles defined by their respective constraints. In this case, layout 0 refers to the top half of the screen and layout 1 refers to the bottom half. Okay. Layout paragraph. It was layout. Okay, layout. So if you split it into this, then you'll have an index layout of 0 and 1. Okay. Nesting layouts. One of the important concepts to understand is that layouts can be nested. This means you can define another layout within a rectangle
of an outer layout. These nested layouts allow complex and flexible UI designs to be built while still maintaining control over how your grid of widgets resides with the terminal window. Okay, so you can have nested layouts. Outer layout 50-50, then split. Okay, F. And then here inner layout, you have 25-75. Split. Okay, what does it mean? Splitting where? Outer layout 1. Okay, so it means that this 25 and 75 are actually inside this one. So 50 is further divided into 25% of 50 and 75% of 50. Because of the index. If this is 0, then I think it would be here. In this situation, the terminal window is initially split vertically into 2 equal parts by outer layout. Then inner layout splits the second, so you see, second rectangle of the outer layout. Horizontally. Okay, so horizontal is like this, from left to right. And if you split 25, then it's somewhere here. Okay, this is 50, so 25 is here, and this one is occupying 75. Okay, here, rendering some paragraphs of text into the above layouts produces the following. Okay, paragraph outer layout. Then inner layout 0. Oh wait. Outer layout is here. Then you have inner layout 0 is here. Inner one is here. But why do we have it vertically? Okay. So it's using this example also. So 50, 50, 25, 75. Okay, constraints. Constraints dictate the size and arrangement of components within layouts. The Ratatui framework provides several constraint types for fine-tuning your user interface's layout. Okay, so constraint length U16. This constraint specifies a specific number of row. Okay, so it's referring to row and columns so the rectangle should take up. Note that this is determined by absolute size and is not responsive to the overall terminal window size. Absolute size. Is it because it's taking up? We're just playing text. Okay, so length, you can have percentage also. Size relative to the size of the parent layout. Or ratio. You can have ratio. You can have minimum. I think what's interesting about minimum is which one was that? Let's search from here. Yeah. So this one is actually occupying the entire section. As long as there's a minimum, so that's the smallest one row that it can collapse or shrink. So minimum is quite interesting. It's like a, what do you call that? Like a spring. Like a spring that stretches. Spring. I already forgot. I think the concept of having a spring was from, what was it, from Java? I think from Java. Yeah, but it's not the Spring Boot of Java, but I think the UI for Java, or I might be wrong also. Okay, so that's the constraint for layout. You have max as well, similar to min. If mixed with percentage or ratio, the component will never exceed the specified maximum size. Caution. The ratio and percentage constraints are defined in terms of the parent size. So it's always dependent on the parent. This may have unexpected side effects in situations where you expect a fixed and flexible size rectangle to be combined in the same layout. Consider using nested layouts or manually calculating the size if necessary to create complex layouts. Constraints can be mixed and matched with a layout to create dynamic and adjustable interfaces. These constraints can be used when defining the layout for an application. Okay, so here, mix and match with the layout. Okay. Other layout approaches. There are a few POCs of using Taffy. Taffy that uses Flexbox. Okay, what is this? Taffy is what? Great, Taffy. Flexbox. A Flexbox or grid algorithm similar to CSS to lay out rectangles. This can work nicely, but is not built into Ratatouille yet. See Taffy in Ratatouille for more details. I think it's could be something new. Okay, Taffy flexible UI layout library. Oh, it implements CSS block. What does it look like? And there, oh, so there's this concept of tree, new leaf, style. Okay, Taffy implements the Flexbox and CSS grid specifications faithfully. I think for those who are used in CSS, then I think it would be easy for you guys to understand this. Yeah, but for me, I'm struggling with CSS also. So what I usually do, I just copy from internet for those usual patterns in CSS. Just reuse. Okay, I don't think we'll be using Taffy anytime soon, but it's good to know that there are those things. Okay, event handling. There are many ways to handle events in the Ratatouille library, mostly because Ratatouille does not directly expose any event catching. The programmer will depend on the chosen backend's library. However, there are a few ways to think about event handling that may help you. While this is not exhaustive list, it covers a few of the more implementations. But remember, the correct way is the one that works for you and your current application. Centralized event handling. So this is the simplest. What does it look like? This is often simply a match on the results event read, and then you have question mark. Pros. This has the advantage of requiring no message passing and allows the programmer to edit all of the possible keyboard events in one place. Cons. However, this particular way of handling events simply does not scale well. Because all events are handled in one place, you'll be unable to split different groups of key bindings out into separate locations. Centralized catching message passing. Okay. This way of handling events involves polling for events in one place and then sending messages calling sub-functions with the event that was caught. So polling for events in one place. That's why it's centralized. Pros. This has similar appeal to the first method in its simplicity. With this paradigm, you can easily split extensive pattern matching into sub-functions that can go into separate files. This way is also the idea often used in basic multi-threaded applications. Because message channels are used to pass multi-threaded safe messages. So message passing. Cons. This method requires a main loop to be running to consistently poll for events in a centralized place. Distributed event loops, segmented applications. In this style, control of the terminal and the main loop to a submodule. In this case, the entire rendering and event handling responsibilities can be safely passed to the submodule. In theory, an application built like this doesn't need a centralized event listener. Pros. There is no centralized event loop that you need to update whenever a new submodule is created. Okay. So it can scale well. Does it mean it can scale well? Okay, there's no centralized event loop that you need to update. New submodule is created. Cons. However, several submodules in your application have similar event handling loops. Okay, so this way could lead to a lot of duplicated code. Somehow you just need to strike a balance, whether you use centralized event handling, centralized catching, or message passing, or distributed event loops. Yeah, but over here, even in this JSON editor, it's quite okay. It's quite okay. Yeah, we have to start from somewhere. We don't need to start from a very complex application. All right, so builder light pattern. What is this? Builder light pattern. In Ratatouille, most widgets and some other objects use the builder light pattern. Is it another concept? Let's open this up and see. From GitHub. Oh, it's a post. Name a cousin of the builder pattern, builder light. Unlike a traditional builder which uses a separate builder object, builder light reuses the object itself to provide builder functionality. Is this Rust? Yeah, so it's Rust. So you have shape. How does it work? Okay, shape, new geometry sphere with radius. Okay, so this geometry sphere with radius, dot with position. Okay, so how is that done? Shape below with position. This is shape with position. Okay, then there's a vector here. Okay, then you can call dot with material. Oh, okay, because it's still shape. Dot with material. Okay. In contrast, the full builder is significantly wordier at the definition site and requires a couple of extra invocations at call site. Okay, shape and then shape builder. This is a struct. Let's see what's the difference here. Okay, shape. Then you are calling builder function where builder will return a shape builder. So you start off with shape, then builder. Okay. So once you have the shape builder will have position geometry material build. Position geometry material build. Yeah. So this one looks like the builder pattern in other programming languages also. Okay, so what's the difference here? Self, okay, self is not a reference, but here self is a reference. Okay, the primary benefit of Builder Lite is that it is an incremental zero-cost evolution from the new method. As such, it is especially useful in contexts where the code evolves rapidly in an uncertain direction. That is, when building applications rather than libraries. To pull a motivational example from work, we had the following typical code. Okay, here manager actor new. Okay, here's a new method with a whole bunch of arguments for various dependencies. What's in here? What we need to do is to add yet another dependency so that it could be overwritten in test. First attempt, just add one more parameter to the new method. So this one is added. However, this change required update of 7 call sites where the new, okay, because you added it here, of course, everything will be required to update. Switching that to a builder light allows us to only modify a single call site where we cared to override the counter. A note on naming. If builder methods are to be used only occasionally, with foo is the best naming. With foo. Okay. So with fancy. In most call sites, make use of builder methods. Just that foo might work better. For Boolean properties, sometimes it makes sense to have both. Okay, interesting. Thank you for the post. Builder light pattern. This allows the object to be created in a single shot with methods that set up how the widget will be displayed without having to store the widget in a variable and mutate it. Builder light pattern consumes self parameter, okay, we have seen that, of each method and returns a value with the updated field self. Example of this form paragraph. Okay. So builder light, we have mutable self and it returns self, which you might call like paragraph new dot block. Okay, because block here will return itself again. So if you have other method or functions, you can just put dot something here. If you reach this page after seeing an error warning on your app's compilation, then it's likely that you are calling the setter method against an object, not storing or using the result. This will have no effect on the actual display of the widget and is usually a mistake. Example, the following code. Text raw wrong. Okay, here. Text raw wrong. It's binded to text and text here calling centered. It should be called like this. Centered. Okay. Or in situations where you want to reuse a widget's setup more than once. Setup more than once. Okay. Text clone centered. Then centered text. And text bold text. Interesting. Okay, so let's move on to rendering. What do we have under rendering? Oops. Okay, so I think it's almost time. So what we can do is the following day we can continue from rendering and then application patterns, backends, and then we'll take a look at the recipes also. So we gone through this jet examples. Yeah. So let's do that on the following day. All right. Thank you so much for accompanying me today. Before I finally end, let me thank my supporters.